In the last module, we have considered the problem of testing H naught, theta is equal to theta naught against alternative theta is greater than theta naught for uniform 0 theta population. And we have seen that there are several UMP tests for this testing problem. In this module, we consider some UMP tests for this testing problem and also find uniformly most powerful test for testing the composite null theta is less than or equal to theta naught against theta greater than theta naught. Here in this module, we also consider the power functions of these uniformly most powerful tests. Now, we see this figure. So, at level alpha, phi naught 2 rejects H naught in the violet region and accepts in the pink region. And you see, if x order n is greater than theta naught, then we reject H naught, and A theta naught is any subset of this pink region, and there we reject H naught, so that the size of the test is alpha. And as phi naught 2 is independent of the choice of theta 1. So, whatever theta 1 greater than theta naught, this is uniformly most powerful at level alpha for testing H naught theta theta naught against theta is greater than theta naught. So, you see, so A theta naught can be any subset of this pink region such that the test is of size alpha, and that is uniformly most powerful test. So, there are several uniformly most powerful tests. Now, choice of A theta naught. One choice is like this: x order n is less than or equal to some constant c, where c is less than theta naught. Now, how can we select c? Choose c such that the size of the test is alpha. So, c satisfies probability x order n less than or equal to c under theta naught, which is alpha. Now, x order n is less than or equal to c means all x1, x2, xn, they are less than or equal to c. So, this probability is same as probability that x1 is less than equal to c, simultaneously x2 is less than equal to c, and xn is less than equal to c. Since x1, x2, xn are independent, so this is same as the product of that. So, product of x1 less than equal to c, x2 less than equal to c, xn less than equal to c, and each probability is c by theta naught. So, this probability is c by theta naught to the power n, which is alpha, so that c is theta naught alpha to the power 1 by, and you see this region A theta naught here. So, this is a small square whose area is c square. So, this is for n2. For general n, this is c to the power n. So, the probability is c to the power n by theta naught to the power n. So, you can calculate this probability using the area of this square also. Now, if we select the region like this, A theta naught is set of x for which maximum of x1, x2, xn is greater than some k for some constant k which is less than theta naught. So, how can you find k? Choose k such that size of the test is alpha. So, k satisfies probability x order n is greater than k under theta naught, which is alpha, that is 1 minus probability x order n is less than or equal to k under theta naught. Now, probability x order n is less than or equal to k is k by theta naught to the power n. We have just derived that in the last slide. Therefore, this probability is 1 minus k by theta naught to the power n, which is alpha. So, k is theta naught 1 minus alpha whole to the power 1 by n. So, other choices of A theta naught, you can select any subset of script x theta naught. Say you can select like this. So, this is your A theta naught. So, this is possible. You can select A theta naught like this and this, so that the total probability of this plus this is alpha under h naught. You can select a region like this, but probability of A theta naught under theta naught, that must be alpha, the size alpha test. Before computing the power function, we state something, we derive some probabilities. Suppose x1, x2, xn follows uniform 0 theta. So, x order n is maximum of x1, x2, xn, and you see the pink region is the sample space. So, take a constant is less than theta. So, a is here. So, what is the probability that x order n is less than or equal to a? That means all the values x1, x2, xn are less than or equal to a, and that probability is definitely a by theta to the power n. Therefore, probability x order n strictly greater than a, that is 1 minus a by theta to the power n. And if b is greater than theta, then probability that x order n is less than or equal to b is 1. Why this is 1? Because x order n less than or equal to theta is 1, and it is greater than theta, that probability is 0. So, probability xn less than equal to b is less than equal to theta, union xn lies between theta to b, and that part is 0. So, definitely this probability is 1, and probability x order n greater than b is definitely 0. Now, power function of different tests. So, we have considered the randomized test, and the randomized test is alpha if x order n less than equal to theta naught, and 1 if x order n greater than theta. Now, how can we find the power function, and what is the power function, or what is the power? Power is probability of rejection of h naught at theta. Theta is greater than theta naught. So, theta is a value under the alternative, and the power function for different values of theta, we have the power function. So, this is a function of theta, where theta is greater than theta naught and theta less than equal to theta naught for different values of theta, and for theta greater than theta naught, this is the power at theta. Now calculate the power function. So expected value of phi naught 1 under theta is value into corresponding probability. So alpha into probability under theta x order n are less than equal to theta naught plus 1 into corresponding probability x order n is greater than theta naught. Now how can you calculate probability x order n less than equal to theta naught? You see here theta naught, if theta is less than theta naught, then definitely x order n greater than theta naught is 0. So theta naught plays the role of B. So if we see the last slide, so B is greater than theta, this probability is 1, and A less than theta, then probability A by theta to the power n. So here x order n greater than theta naught, so theta naught is like B, so that probability is 0, and less than equal to theta naught, so that probability x order n less than equal to theta naught, that is 1. So alpha into 1 plus 1 into 0, that is alpha. So if theta less than equal to theta naught, power function is alpha, and if theta greater than theta naught, then theta naught plays the role of A. So probability x order n is less than or equal to theta naught is theta naught by theta to the power n. So alpha into theta naught by theta to the power n plus probability x order n greater than theta naught 1 minus theta naught by theta to the power n. So this is the power function of this randomized test, and you see, so this is initially alpha, and then it is 1 minus alpha into theta naught by theta to the power n. And you see, as theta increases, 1 by theta decreases, so theta naught by theta decreases, theta naught by theta to the power n decreases, and minus sign is there, so overall it increases. So this power function increases as theta increases. So definitely the power function of theta is less than or equal to alpha for all theta less than equal to theta naught, because the beta phi 0 1 theta is less than equal to beta phi 0 1 theta naught, and beta phi 0 1 theta naught is nothing but alpha. Therefore, this is less than or equal to alpha. So phi naught 1 is uniformly most powerful at level alpha for testing H naught prime that theta is less than or equal to theta naught against H1 theta is greater than theta naught. So this is not only uniformly most powerful for testing theta naught against theta greater than theta naught, for composite alternatives and composite null, this is uniformly most powerful. So this composite null hypothesis is theta is less than or equal to theta naught against theta greater than theta naught. This is uniformly most. Now we consider the non-randomized test and the power function of that test. Here phi naught 2 is 1 if x order n greater than theta naught, and take 1 if x belongs to a theta naught, where a theta naught is a subset of script x theta naught, so that the size of the test is alpha. So we have shown that this is uniformly most powerful for testing theta naught against theta greater than theta naught. And we will look at the power function of the special forms we have already considered. One is x order n less than or equal to c, and other x order n is greater than k. So, first consider x order n greater than k. So, we have found that k is theta naught to 1 minus alpha to the power 1 by n, and then the test becomes phi naught 2 is 0 if x order n is less than or equal to theta naught 1 minus alpha to the power 1 by n and 1 otherwise. So, power function of this test is just 1 into probability x order n greater than theta naught 1 minus alpha to the power 1 by n. If theta is less than equal to theta naught 1 minus alpha to the power n, it is 0, because here you see theta naught 1 minus alpha to the power 1 by n plays the role of b. We have shown that probability x n greater than b, that is 0. And if theta greater than theta naught 1 minus alpha to the power 1 by n, it is 1 minus alpha theta naught by theta to the power n. This is the power function. So, initially it is 0, then it is an increasing function of theta. So, beta phi naught 2 theta is less than or equal to beta phi naught 2 theta naught, and beta phi naught 2 theta naught is alpha. So, this phi naught 2 is also uniformly most powerful at level alpha for testing h naught prime theta is less than equal to theta naught against h1 theta is greater than theta naught. So, we have found another uniformly most powerful at level alpha test for testing this composite null against this composite alternative h1 theta greater than theta naught. Now, what about this test where a theta naught is maximum of x1, x2, xn is less than or equal to c. So, we have seen size restriction forces c as theta naught alpha to the power 1 by n. Then the test becomes phi naught to x is 1 if x order n is less than or equal to theta naught alpha to the power 1 by n, or x order n greater than theta naught and 0 otherwise. So, this is the form if we take this c as theta naught alpha to the power 1 by n and region a theta naught at x order n less than or equal to c. And we can calculate immediately the power function of the test as probability x order n greater than theta naught plus probability x order n is less than or equal to theta naught alpha to the power 1 by n, and alpha theta naught by theta to the power n if theta lies between theta naught alpha to the power 1 by n to theta naught, and if theta greater than theta naught is 1 minus alpha theta naught by theta to the power n. Now, you see that the second one alpha theta naught by theta to the power n is a decreasing function of theta. As theta increases, theta naught by theta to the power n decreases. Initially 1, then decreases, and then at theta naught it is alpha, again it increases. So, the power function of the test looks like this. So, this is U-shaped with a minimum value of alpha at theta naught. Though this test is uniformly most powerful for testing theta theta naught versus theta greater than theta naught, it is not uniformly most powerful for testing theta less than equal to theta naught against theta strictly greater than theta. So, in this module we have shown that uniformly most powerful test for testing composite null hypothesis like theta is less than or equal to theta naught against theta is greater than theta naught is not unique. So, we have considered two uniformly most powerful tests for testing this composite null against composite alternative. But we have another test which is not uniformly most powerful for testing this composite null against composite alternative, but that is uniformly most powerful for testing theta theta naught against theta not equal to theta naught, which we will show in the next module.